Hey guys, so I just had a math midterm today. It's funny, I was studying for 3 days straight for this midterm, and like it turns out it was so much easier than I thought it was gonna be. I was defending it like the Navy, man. Seriously. So yeah, this is just me going over the questions and what my answer was, and thinking what I'm gonna get overall. So there were 4 questions. It's out of 20. Question 1A, show that f of z is equals e to the power of z is entire. You can read it. Okay, but show that f of z equals z conjugate is not analytic anywhere. So an entire function is where the Cauchy-Riemann equations u of x equals v of y and u of y equals negative v of x are satisfied throughout the entire complex plane. And the partial derivatives are continuous across the entire domain. So here, as you can see, u is equal to e to the power of x cos y, and v is e to the power of x sine y. If you were to differentiate this with respect to x, that's just e to the x cos y, and the Cauchy-Riemanns are obviously satisfied, and they're continuous across the entire domain. So f is entire, it's analytic everywhere. For f of z is z conjugate, you can say that's equal to x minus iy, because z is just x plus y, so you just flip it. U of y is equal to v of x, and that's 0, but u of x is never equal to v of y across the domain, so it's nowhere analytic. This reminds me, I remember I was studying that functions can have continuous partial derivatives in the complex plane, yet still be nowhere analytic, which is a surprising fact, but it's true. Question 2. I was able to do this for the most part. F of z is z to the power of I. Absolute value of z is greater than 0, and then you have this angle, and it's from 0 to pi. And there's a positive orientation, right? Okay, well, I wrote this because I remember I learned in class that z to the power of c is any complex constant. That's e to the power of c log z, which in this case is I. Now z is log z is ln of the absolute value of z plus I theta. Well, the absolute value of e to the power of I theta is just 1, right? So ln of 1 is 0. So you have e times I to the power of I times I theta, which is e to the negative theta. But I did a slightly different approach. Both work, but here I just said that z to the power of I is e to the power of I theta because z is e to the power of I theta. And then I multiplied it by I because you can multiply exponents and then you get e to the negative theta. And it's a good thing we didn't have to prove this. The contour f of z of theta times z prime theta d theta. And they said it was from pi to 0. F of z of theta is e to the negative theta. And then f prime of z is just z prime of theta is I theta, because you bring out the I to the front. And then I was able to evaluate it. For question 3, the singularities of a rational function are just where the denominator is 0. There's like really not much to it. I learned that in class and I just remembered it. For the circle, for part B, I used something called lemma, which it was like, it's an upper bound for an integral where it's an upper bound for an integral where it's like, what does the contour, like when you revolve it around a place, what's it no greater than? And so you have f of z is, and I use something like the triangle inequality. So in the absolute value of f of z is no greater than a number m, a positive number m. 1 is equal to 1. This is always true. So let's focus on the denominator. So if the numerator of something is less than or equal to something, but the denominator must be greater than or equal to in comparison for one fraction to be less than another. So that means z to the power 4 minus 5z squared plus 4 has to be greater than or equal to something to set a bound. And this is I use the triangle inequality. So z squared minus 1, the absolute value of this, is greater than or equal to z, absolute value of z squared minus 1, which is, and the absolute value of z is 3, so that's 9 minus 1 is equal to 8. And I did the same thing here. There was a homework assignment in my class where it was like, if you prove the triangle inequality, if it was like the absolute value of z1 plus the absolute value of z2 is less than or equal to, the absolute value in total of z1 plus z2 is less than or equal to the absolute value of z1 plus the absolute value of z2, then you can say that also the absolute value of z1 minus z2 is greater than or equal to the absolute value of z1 minus the absolute value of z2. So if it had been z to the power of 4 plus 5c squared plus 4, you would have also gotten the numbers 8 and 5 respectively. And then you multiply out the absolute value and you get 1 over 40, which is equal to m, which I achieved and showed 1 over 40 here. I was on the train, on the SkyTrain home today, and I was thinking, what if I did the absolute value of z to the power of 4, that would be 81, minus 5z squared, absolute value of z squared, that would be 45 plus 4. You would also seem to get 40 there. I didn't try because it was risky, but it seems to also provide an answer. I'm going to ask one of my professors soon. For question 4, it was like show that the Cauchy-Riemann equations are satisfied, yet the function is still not differentiable there. In general rule of thumb, for it to be differentiable at a certain point, the equations have to satisfy, but the partials have to be continuous at that point too, because if something's not continuous, it's not differentiable. Differentiability, the contrapositive is true. Differentiability implies continuity. So that's what I had for A. For part B, I just explained what a contour was. Pause it and take a look at it if you like. Part C is the one I'm most concerned about. I kind of BS'd my way through this, but at least I was able to solve every single question on the test. And based on like what I've learned, I think I could I'm pretty confident with 1 and 3. And question 2, I'm just worried that the angle, the branch is slightly different than I get. But I think a lot of math courses, as long as you give a serious attempt, you should get some points. So I think I've locked in at least 14 or 15 out of 20. It might be possible I can even get 90. So yeah, that's what I have for today. Sorry, I haven't been uploading videos. I wanted to upload this video to show you why I haven't been uploading. So yeah, see you guys around.